This is a lesson video, so you just have to watch the lesson and then fill out the guided notes. Everything that I talk about and ask you to do in the guided notes, I'm going to go over in this video. So this is just to see that you're watching and paying attention to the lessons. All right, so we talked about the main ingredients of hypothesis testing. One, come up with a hypothesis. Two, minimize the mistakes. Find the test hypothesis, and then calculate the surprise, the p-value. What we're going to talk about today is the actual steps in doing this stuff. So one is hypothesize, two is prepare, three is compute to compare, and then four is interpret. And I'm going to go through each of these steps with one problem. And if you're playing along, I would pause the video and copy this into your guided notes. I just went over two things that should be in your guided notes. All right, let's talk about step two. So step one, we kind of talked a lot about 2 weeks ago when we introduced this idea of hypothesis testing, where we have a null hypothesis and an alternative hypothesis. So number two, it looks very familiar, right? We have to test four conditions to see if we can do what we do to calculate the p-value. So we have to make sure our sample is random. We have to make sure that it's a large enough sample by following this formula that we've learned before. We have to make sure we have a large population, and we have to make sure that our sample is independent of each other, right? Now, we're going to go back to this question about the e-readers. So it's on the second page of your guided notes. So about 10% of Americans own an e-reader in 2011. In January 2012, after the holidays, the Pew Research Center conducted a survey of 1,377 randomly, very important, right? They tell us it's random, selected adults, and found that 90% of them owned an e-reader. Can the publisher conclude that the e-reader ownership increased over the holiday? So first things first is step one, right? So I want to see this in your guided notes. H naught, or your null hypothesis, is equal to 10%. And the alternative hypothesis, and now this is important, folks. So for last week, we talked about the Z statistic. We've really focused more on the null hypothesis. We didn't talk about the alternative hypothesis. Now we need it for the p-value, and I'm going to show you why shortly. Here, we want to see if it's bigger than 10%. And remember, the big difference between the alternative and the null is the null, we're going to have equals, right? It's going to be less than or equal to, greater than or equal to, or equal to. And for the alternative hypothesis, it's always going to be either less than, greater than, or not equal to. That's how you can tell if you ever get confused. All right, now this is step two. We're going to say, is this random? Well, we were told it was random. We were told in the word problem it was random. So yes, it's random. Step two, I do the steps, right? I multiply the sample size, which is 1,377 by 10%, and I get 137. Whew, that's bigger than 10. That's great. Then I do the same thing with 1 minus 0.10, which is 0.9, and that's 1,239, also a bit bigger than 10. So we're good. Large population. U.S. population is easily greater than 10 times 1,377, which is the sample size. So we're good, right? And then for independence, we assume the pollsters surveyed people in such a way that their responses were independent of each other. And we can make that assumption, by the way, because it's the company that's doing it is a very famous company that, does this stuff. So we can make these assumptions when it comes to number four. I want to see in your problem sets, though, I want to see 2 and 3 addressed, okay? Basically, 1 and 4, you can copy and paste this from your guided notes into the problem sets for the rest of the week. All right, step 3, compute to compare. So here, there's 2 steps. One is we compute the Z statistics, and the formula is right here. And then 2, we compute the p-value. And I'm going to show you how to compute the p-value. Honestly, folks, nowadays the p-value is software is used to compute it. And in fact, that's why hypothesis testing is not even really covered in your college class if you take it next year at Bronx Community. It is covered, though, at Hunter. It is covered at in other institutions. For whatever reason, Bronx Community doesn't cover it. So all you have to do, but it's still great practice for central limit theorem and all that other stuff. So it's still a good thing to do. So what we're going to do is we're going to, use our tools to compute the z-statistic. And we actually already kind of did this a while ago. Remember, and I'm going to put this calculate in every assignment this week, so that way you guys are good, is you go to desmos.com scientific, and you just put in the formula, right? So we got 0.19 for our sample, and we minus that from the null hypothesis. Then we are going to take the square root, and we're going to do the null hypothesis, parentheses 1 minus the null hypothesis, close the parentheses, and then go down and put the sample size, which is 1377. And we get 11.13, right? So we go back and we, okay, we're going to put that, sorry guys, I kind of got ahead of myself. So we're going to put 11.13 here. All right, so now we're ready. And here, I'll make it. And if you could, for your guided notes, just copy down these steps, right? So and just show the math work. So you can it doesn't have to look like this. You can write p hat, like p comma, like if you don't want to use the notations here, you can write p and then hat, right? Like that, p hat. All right. But if you want to, the way Mr. Pilisher got this is I used all Microsoft products have it. You go to insert and you go to equation and you press this button. You press this, it's a bunch of equations, but you want this equation, so that way you can edit it. Here is the fractions and the subscripts. So fractions here, subscript is here, and then if you want an accent like the p hat, it's right here. But don't go nuts, guys. But do show your steps. Your problem sets this week will be on the small side because each problem set requires 4 different steps. So I'm not going to give you a lot of problems to do, but I do want you to be very precise in doing it and showing your steps. All right, enough about that. Let's get back to the lesson. I just want to talk about the p-value. Okay, so the p-value is a probability that if the null hypothesis were true, we would get a statistic as extreme or more extreme than the observed test statistic. So what does that mean? It just means that if the null hypothesis is true and we do a study and we take a sample, how crazy is it to get the proportion we got in that sample that we got? So for example, like how crazy is it that we got, if it's supposed to be 10, how crazy is it that we got 19? Is it crazy enough to say that the null hypothesis is not true anymore and we can throw it out and then therefore use the alternative hypothesis? Well, the first thing you have to do that is understand this. There's 2 types of p-values. There's a thing called a two-tailed value, and you only really see it if, let's pick up my marker to show you guys. Only see it if this is not equal to whatever number. Okay, then we're going to use two-tailed. That's honestly, guys, that's the only thing you have to remember. Two-tailed only if the alternative hypothesis does not equal A. Now, one-tailed, if we use one of these, either less than or greater than, and that's important to know which one we used. So when you're gonna, like, for example, for our here, we say that this is greater than, we're gonna have to remember that because we're going to use that. Oh, you see that, Mr. Pilisher made a mistake, right? I shouldn't have put those lines underneath. It should just be this. I got excited, I guess. So you need to remember which one you used in order to get the right tail. And this sounds weird. I'm going to show you in this step. So watch what I do. So I'm going to go to my calculator, but not my Desmos calculator, my p-value calculator, which I also will put in the notes. So 11.13 is my test statistic. My sample size is 1,377. Now here's the thing where you need to know. So right tail, that really won't make sense to you, but what you have to do is you just have to look at here, right here. This is the we said H naught was here, which was 0.10. So all we have to say is, was HA greater than or less than 0.10? So we said it was greater than, so it's going to be greater than. Now, if we said less than, we're going to put less than. It would be left tail. Now, if we had not equal to, it would be called two tail, and we would hit two tail, okay? What I need you guys to do, so this one was greater than, so we're going to go right tail. Significance level, guys, is always going to be 5% for our class, but we are going to talk about it. The significance level is the thing that the p-value is kind of judged against to determine, if we can throw away the null hypothesis or not. Again, right, we're going to use technology, so I don't want you freaking out about, like, what, like, I just want you to look at how Mr. Pilisher puts it into his technology, and then we're going to talk about what happens next. So basically, for all your problems, you're copying the test statistic here, you're copying the sample size here, and here's where you're looking at your alternative hypothesis, and based on what you wrote, you're going to select one of these. Okay? Always leave this at 5%, hit compute p-value, and it does it. Now, I want you guys to use the snippet tool and copy and paste this. If you don't have Microsoft, you can also just do a screen grab and copy and paste it, and then crop it in your document, right? Or I don't care, just copy and paste it. I don't care if I see the ad in there. If I know that you came up with the normal curve, and it does a really great job of, that's why I like this calculator. It kind of shows you where it falls on the normal curve to give you an idea of why the response is. And look at what this calculator do. The p-value is basically zero. The p-value is statistically significant because it shows that we can reject the null hypothesis. So I love this calculator because it tells you exactly you can reject the null hypothesis. So based on our experiment, right, our p-value was able to kind of to throw out the null hypothesis. Really quickly, just in case you're wondering, left tail, right? It's the left side of the standard the normal curve. Right tailed, it's on the right side. And remember, we do those four conditions to be able to use the normal curve. That's for everything we've done this year. We're doing these four conditions because we want to use this thing because it's so nice to be able to make predictions. And then when you hit two tailed, you'll get two tails, like on both sides, because not equal to means that it could be less than or greater than. That's why it's called two tailed. All right, so we computed the p-value, right? Oh, whoops. And the p-value we're going to say is we just copy it from the website. So p-value, it says it right here. It's basically 0%. So you can write 0%. That's fine. And then for interpret p, all you have to do, I mean, if you want to, you can copy and paste this. The p-value is statistically significant. Yeah, we can even say claim hypothesis if you wanted to. So in your notes, you're just gonna copy that from the calculator. All right. So if you're confused about this, we're gonna practice it over over the whole week. This is honestly, guys, there's not gonna be any other lessons. If I post a video, it's to help you with the problem that I saw, but we're just practicing the whole week doing these four steps in being able to toss a null hypothesis or not. The problem sets will not have that many problems because I want you to practice, but just follow the steps and use your guided notes, okay? When I check your guided notes today, I'm looking to see that you've done all the steps. All right, I'm looking to see that I want to see this formula. I want to see, if you wanted to, you could just copy and paste this whole section right here. And that's not only your p-value, it's also your interpretation right there. So I don't want you to freak out. I don't want you to overcomplicate it. But if you do feel overwhelmed, guys, please contact me, okay? I'm very proud of you guys. You guys are rising to the occasion. Some of you, I'm having conferences, and I can hear your siblings in the background. I'm so proud of you. So just, reach out, okay? And if you're falling behind because this is a little overwhelming, just let me know. It's not the end of the world, okay? All right. Till next time.